Hey everyone, this is the Introduction to the Year 11 Math Methods course. In this video, I'm going to be going over what to expect from Math Methods, what university courses you should be aiming for or are aiming for if you're undertaking Math Methods, and then a couple of recommended textbooks before I get into the way I'm going to teach this course. So we'll get into it. So the first thing, this is just something I've pasted from the SCARSA website. The Math Methods course focuses on the use of calculus and statistical analysis. And in that way, it is a foundational math unit for a lot of university courses that use calculus. So some of the courses I've found online by checking through, for example, UWA and Curtin, engineering, computer science, medicine, maths, higher math, that is tertiary mathematics, biomedical science, agricultural science, and environmental science. Those are all examples of courses that have mathematics methods as prerequisites. But if your course isn't on there, you can find that on the university websites. And it'll be different depending on the university. So if you're interested in going over east or also internationally, there will be requirements associated with that as well. So recommended textbooks. These are just the textbooks I had experience with myself, and I think comprehensively they prepared me quite well for my studies. So the first one, A.J. Sadler, they generally come as single unit textbooks because the math methods course is split into two units, Unit 1 and Unit 2. Unit 1 is generally what's taught in the first semester, and Unit 2 is what's taught in the second semester. And that's roughly the order I've followed in my teaching of the syllabus, the way I've planned it. So the Sadler questions generally have routine questions. They won't be too difficult, but they're generally there for you to gain a sense of familiarity with the types of questions and the concepts that'll be asked in your tests and exams. So this is something I really advise that you go over. It's not enough to just listen to me talk for each of the concepts. You're going to need a lot of mathematics is about practice. And so these are the textbooks I would recommend. Nelson is generally slightly harder questions. I think they would generally have less accessible explanations of concepts, but they do have more difficult questions that are closer probably to the tests and exams. Test and exam questions you'll deal with. OT Lee, generally, I find OT Lee more difficult than tests and exams, computationally especially. They have a lot of, in terms of the calculator-free sections, expect to be computing large numbers. So don't be too discouraged if you're finding OT Lee difficult. Okay, so now we'll move on to the syllabus, and before I start, I acknowledge that I did get these bullet points for the concepts from the School Curriculums and Standards Authority website that I will link below in my description. Okay, let's get cracking. So the first topic I'll go over is on counting and probability. This is listed as Unit 1, Topic 1 in the SCARSA syllabus. So the first video I'll be going over combinatorics. So in methods specifically, you only deal with combinations. The other part of combinatorics, which is referred to as permutations, is something that's taught in the mathematics specialist course. Probability, this is the second video that I'll go over. And then following this, I'll be going over functions and graph, trigonometric functions, and exponential functions. I've grouped all of these three topics together, even though they're listed as separate topics in the SCARSA syllabus. I've grouped these together because they all deal with related concepts, and particularly when you come to a formalized definition of the functions concept, it's good to have already covered exponential functions, in my opinion. So the first video I'll go over is lines and linear relationships. This is probably something you've dealt with in year 7 up to 10 already, and so this will be hopefully something relatively easy for you, something you'll revisit. Similarly with quadratic relationships and parabolas, parabolas are the graphic representation of quadratic relationships on a Cartesian plane. And hopefully you'll have gone over some of quadratics from year 7 to 10. If you haven't, not to worry, I will go over that, and you can pose questions in the discussion section. in the comments section, that is. Powers and polynomials. This is extending. Generally, I don't think you'll have covered cubics, but you deal with cubics and higher degree polynomials. We'll come to a definition of what a polynomial is and look at the characteristics of polynomials for different values of x and y. Inverse proportion and hyperbolas. Hyperbolas, again, are generally the Cartesian representation of inverse proportion, so we'll go over this as well. Then we'll take a brief hiatus from functions and look at index laws, and index laws directly tie into exponential functions, which we'll go over in a second video. Finally, after we've illustrated what a function is based on all of those previous functions, you'll notice we'll have said the word function quite a bit in each of those title slides. We will come to a formalized definition of what a function actually is, and looking at how a function behaves, how the general function behaves when we do different things called transformations to those functions. Following functions, now that we've come to a definition of what functions are, we'll differentiate them from relations, which are a separate category of, well, relations between y and x. After we've dealt with functions, we move on to SCASA Unit 2, Topic 2, which is on arithmetic and geometric sequences. I've titled this video Arithmetic Sequences and Series, even though in SCASA they only title it Arithmetic Sequences. They do mention series within, I think it's point 2.2.4. That is the definition of an arithmetic series. The next video on geometric sequences and series, again, they haven't titled a geometric series within this, but I would consider that a separate concept. So that is something I have included in the title. Finally, this is the last topic of Year 11 methods. It's the Introduction to Differential Calculus. This is SCASA Unit 2, Topic 3, and this basically sets the baseline for a lot of what you'll do in Year 12 methods and Year 12 specialist. Year 12 methods is especially calculus heavy. So the first video will deal with the rates of change and the concept of a derivative. I've grouped these two together because the concept of a derivative I find is a natural continuation of what a rate of change is. Where rates of change include average rates of change, the concept of a derivative refers to an instantaneous rate of change. So we'll deal with both of those concepts in one video. All right, next slide. Then we'll go over computation and properties of derivatives once we've come from the definition of what a derivative is. And finally, sorry, not finally, this is one more and then we'll have one last one. This one will go over applications of derivatives. So once we've defined what a derivative is and defined how we compute it, we can apply it to real world situations. And the last topic that is covered in Mathematics Methods Year 11 is antiderivatives, and this will be formally defined as a separate branch of calculus known as integral calculus, and anti-differentiation will be referred to as integration. Integration and anti-differentiation are generally referred to interchangeably. That was the word I was looking for. But other than that, that is everything for Year 11 Math Methods, and I will upload videos for this hopefully in the next week.